The planet had already lived through 4 centuries that no one aboard the ship could see. Its pale oceans, dark continents, and narrow bands of cloud reached them through light that had begun its journey long before the vessel left Earth. Every image displayed in the observation hall belonged to an ancient season. Every atmospheric spectrum described air that might have changed beyond recognition. When children pressed their hands against the illuminated map of the destination, they touched a world preserved in the past, while the real planet continued moving through storms, winters, impacts, eruptions, and the slow alteration of its star. The ship carried more than 20,000 people toward that uncertainty. It carried forests arranged in rotating chambers, embryos sealed behind radiation shielding, machines able to manufacture their own replacements, and archives containing languages whose last speakers would die during the crossing. Its engines had burned for years to build the velocity that now carried it between the stars. Turning around would demand another civilization's worth of energy. Stopping at the destination would require the engines to awaken centuries after their construction, under the hands of engineers descended from people who had never seen them operate at full power. No one could guarantee that the planet would still be habitable when they arrived. The mission had begun because the world seemed promising, because its mass resembled Earth's, because its orbit allowed temperatures compatible with liquid water, and because faint patterns in its atmosphere had encouraged a generation desperate to believe. Those measurements had never been a promise. The passengers would spend centuries traveling toward a conclusion that may already have occurred, carrying an entire civilization into the darkness before nature revealed whether there would be ground beneath its future. The decision to launch had taken less than a century, although its consequences were expected to continue for nearly 6. Astronomers had studied the planet through several generations of telescopes. They measured the slight dimming of its star during transits, the gravitational movement caused by its orbit, and the colors filtered through the upper layers of its atmosphere. Each instrument added detail. None produced the certainty demanded by a journey of such length. The planet appeared rocky. Its gravity seemed close enough to Earth's for human bodies to adapt. Water vapor had been reported with caution, followed by possible clouds and seasonal variations in atmospheric chemistry. Models produced oceans, frozen basins, deserts, temperate coastlines, and worlds covered entirely in water. The same data permitted several incompatible planets because distance reduced a living world to small changes in light. Public imagination selected the most beautiful interpretation. Artists painted green continents beneath a copper sunset. Documentaries showed waves breaking against black volcanic shores. Children learned the planet's temporary name before astronomers had confirmed whether its surface was visible beneath clouds. Governments spoke of a second home, though every careful scientific report contained pages of uncertainty. The launch became a response to hope rather than proof. Earth possessed no probe capable of reaching the planet before the generation ship. A small robotic craft could travel faster, although even its data would arrive too late to guide the original departure. Waiting for certainty meant delaying the mission by centuries. The people who approved the launch understood that the choice lay between traveling toward an imperfectly known world and remaining within the solar system until another age. The first passengers remembered the arguments. They remembered scientists explaining atmospheric false signals to political leaders who wanted simple answers. Oxygen could arise through biological processes, though certain planetary conditions could also produce it without life. Methane could suggest active chemistry and perhaps organisms, while volcanoes or reactions within rock offered other explanations. Clouds could hide the surface. A thick atmosphere could keep oceans warm or turn the planet into an immense greenhouse. Every hopeful discovery generated a quieter paper questioning its meaning. The public rarely gave equal attention to both. The mission had gathered momentum through decades of investment, construction, and cultural preparation. Industries depended upon it. Nations had contributed habitats and engines. Families had competed for places aboard. Once the vessel existed in orbit, doubt began to sound like an argument for abandoning the greatest structure humanity had ever built. The founders did not consider themselves reckless. They had chosen a destination through the best science available. The target star appeared stable enough for a long-lived planetary system. The world remained inside a region where surface water could exist under suitable atmospheric conditions. No nearby candidate offered a clearly safer future. The uncertainty belonged to every possible interstellar journey. What disturbed them was the difference between scientific probability and inherited destiny. A mission planner could accept a 60% chance of habitability as favorable. A child born aboard would receive that probability as the foundation of an entire life. The number would shape education, reproduction, labor, and the direction of the ship, while the child had no opportunity to choose another world. Departure transformed the planet from an astronomical candidate into a civic purpose. Its image appeared in schools, medical centers, agricultural chambers, and public halls. Streets within the rotating habitats carried names taken from coastlines that existed only in climate models. One residential district was called Meridian Bay, although no telescope had ever shown a bay there. A garden was named the First Valley, long before anyone knew whether valleys crossed the destination's surface. The symbols helped the founders endure separation from Earth. They needed a future large enough to balance everything left behind. The planet became a destination, inheritance, memorial, and promise. Its imagined landscapes absorbed grief that might otherwise have turned toward the mission itself. The first generation could still distinguish between data and art. They knew the famous blue-green globe was a reconstruction. Labels beneath public images explained the uncertainty. In ordinary conversation, those distinctions softened. People spoke of future rain, future soil, and the first city beneath an open sky. Children asked which ocean their grandchildren would see from the landing site. Language gave the planet a reality that instruments had never provided. The phrase "when we arrive" replaced "if we can land." Political speeches described the surface in the future tense. Scientists continued correcting the public record, though their cautious words seemed increasingly remote from the emotional needs of the voyage. During the first decades, Earth continued sending improved observations. Larger telescopes entered operation after the ship departed. New instruments separated the planet's light from that of its star with greater precision. The passengers received these results after delays that lengthened every year. At first, the reports strengthened confidence. Atmospheric pressure appeared substantial enough to support stable surface conditions. The estimated temperature remained compatible with regions of liquid water. Clouds showed patterns that could reflect an active water cycle. Celebrations spread across the ship when one study suggested a broad ocean within the illuminated hemisphere. Later, analyses complicated the picture. The star produced stronger ultraviolet activity than early models had assumed. Several powerful flares had been observed during a brief monitoring period. Researchers disagreed over whether the planet's magnetic field and atmosphere could withstand centuries of such exposure. Some simulations preserved a habitable surface, others removed much of the water and air. The reports arrived as fragments from an Earth receding into the past. By the time the ship received a warning, astronomers at home had already spent years reconsidering it. Their later conclusions remained in transit. The passengers lived within a chain of unfinished knowledge, each message correcting an earlier version while another correction crossed the distance behind it. The planet's star was smaller and cooler than the Sun. Its dimmer light placed the habitable region closer to the stellar surface. The target world completed its orbit quickly, passing through a year in a fraction of the time once required by Earth. Its proximity to the star raised the possibility that gravitational tides had gradually locked its rotation. A tidally locked planet would keep one hemisphere facing the star while the opposite side remained in continuous darkness. Early public images had shown sunrises, sunsets, and familiar day-night cycles. Later generations learned that the planet might possess a permanent day, a permanent night, and a ring of twilight between them. This arrangement did not automatically make the world uninhabitable. A sufficiently thick atmosphere and active ocean could move heat from the illuminated side toward the darkness. Clouds might gather above the point facing the star, reflecting enough energy to prevent extreme heating. Winds could flow constantly across the terminator, connecting climates beneath a motionless sun. The same possibilities created new dangers. A thin atmosphere could freeze onto the night side. Powerful circulation might generate continuous storms. Water could become trapped as ice in the darkness, leaving the illuminated hemisphere dry. Habitability might exist only within a narrow belt where temperature, light, and atmospheric movement reached a temporary balance. The settlers had once imagined choosing among continents. Their descendants might be confined to a corridor extending around the planet, living forever beneath a star resting near the horizon. The ship's education system taught uncertainty as a discipline. Students examined competing climate models and learned why each depended upon assumptions that could not yet be verified. They studied how atmosphere, ocean, ice, clouds, volcanic gases, and stellar radiation interacted across time. The destination was presented as a set of possible worlds sharing one orbit. Children responded differently. Some found the ambiguity beautiful, a reminder that they were traveling toward genuine discovery. Others experienced it as a source of quiet terror. Their homes, professions, and possible children depended upon conditions represented by colored maps produced centuries earlier. The youngest students often asked the simplest question: what is the planet like now? Teachers explained light travel, distance, and the impossibility of receiving present information. The answer remained difficult to accept. The planet was real, and its current state existed somewhere ahead. Human knowledge stopped at an invisible historical boundary. A classroom could display the newest image available while acknowledging that the world shown had already moved hundreds of times around its star since the light departed. Storms had crossed the oceans. Volcanoes may have altered the atmosphere. Ice had advanced or retreated. A biosphere could have expanded, collapsed, or transformed. The mission's destination existed beyond observation in the same way the ship's future existed beyond prediction. Both moved forward while the inhabitants occupied the interval between them. The first major political crisis began with a set of atmospheric measurements transmitted from Earth during the ship's 73rd year. The new telescope had detected a pattern consistent with severe atmospheric escape. Hydrogen appeared to be streaming away from the planet under the influence of stellar radiation. The findings suggested that water molecules were being broken apart in the upper atmosphere, allowing their lightest component to vanish into space. The scientists who sent the report emphasized uncertainty. The observation covered a limited period and required interpretation through complex models. The escape could be ancient, temporary, or replenished by geological processes. The planet might still hold immense reservoirs of water. The surface conditions remained unknown. The ship received the report during a time of social stability. Its first generation had grown old. The people governing the vessel had been born aboard and had organized their lives around a destination they considered real. Public release of the data triggered demonstrations, emergency debates, and accusations that the founders had concealed the risk. The records showed no concealment. Early mission documents had included atmospheric loss among the possibilities. Few passengers had read the technical appendices. The culture of arrival had transformed probability into expectation, and many people now treated uncertainty as evidence of betrayal. Several factions emerged. The Continuity Council argued that one observation could not justify altering a mission planned across centuries. The target remained the most thoroughly studied world within reach. The ship possessed enough resources to survive in orbit if the surface proved hostile. New information would continue arriving. The revisionists demanded an immediate survey of alternative stars. They argued that the vessel's trajectory should remain flexible while sufficient fuel and distance remained for a major correction. Waiting for certainty would allow options to disappear. A different planet, less promising at departure, might now offer a safer destination. A third movement rejected planetary settlement entirely. Its members believed that the ship should become the permanent center of a mobile civilization, gathering resources from asteroids and small worlds after reaching any suitable star system. The destination planet had inspired the mission, though survival no longer required living on its surface. The disagreement reached into families. Parents who had taught children to prepare for planetary life now questioned the meaning of that education. Engineers recalculated propulsion reserves. Ecologists examined whether the ship's biosphere could continue for additional centuries. Historians returned to launch-era debates that had once seemed ceremonial. For the first time, the planet ahead became a source of division greater than the Earth behind them. Changing destination carried physical costs that political speeches could not remove. The ship had accelerated along a carefully selected route. Its mass included habitats, shielding, fuel, factories, water, and a population expected to grow across generations. Altering velocity by even a modest amount required enormous energy. Some alternative stars lay outside the vessel's reachable corridor. Others would add centuries to the voyage. A planet that appeared promising from Earth could be just as uncertain, observed through light even older than the information available for the original target. Changing course might exchange one unknown world for another while weakening the ship through a longer journey. The engineers presented charts showing fuel margins for arrival. The main engines needed enough reaction mass and energy to slow the vessel within the target system. Spending too much on course correction could leave the ship unable to stop. A new destination would have to align closely enough with the current velocity to remain physically possible. The public discovered that interstellar travel created political captivity through momentum. The ship possessed engines, navigation, and a theoretical freedom to turn. Its accumulated speed made certain choices practically irreversible. Decisions made at launch had become embedded in the movement of thousands of tons through space. The generation living through the crisis had not approved those decisions. They inherited velocity alongside language, law, and genes. The debate ended without resolution. The Council authorized continued observation, expanded research on alternative systems, and reserved fuel for a possible correction. The ship maintained its path while officially recognizing that arrival on the planet was no longer guaranteed. This compromise entered the civic language as the open destination doctrine. The vessel was traveling toward the target system, though settlement would depend upon evidence available closer to arrival. Habitats, moons, asteroids, and neighboring worlds were added to mission planning. Children learned that their descendants might live beneath a sky, inside an orbital city, or aboard the ship indefinitely. The change relieved some anxiety and weakened a source of unity. The founders had offered one future. The open destination doctrine offered several, each uncertain. Citizens could support the mission while imagining incompatible outcomes. Artists began painting the planet differently. Earlier images showed wide landscapes ready for settlement. New works depicted it partly hidden by cloud, darkness, or distance. The most famous painting of the 2nd century showed the planet as a faint crescent reflected in an observation window, with the faces of the passengers visible more clearly than the world ahead. The mission's central symbol became a question. While the society reconsidered its destination, the ship continued aging. Its earliest systems had been designed for replacement, though replacement never reproduced them perfectly. New pumps used alloys manufactured from recycled material. Computers migrated across generations of hardware. Seals, cables, lights, bearings, and valves were rebuilt through processes developed aboard. Every reconstruction introduced small differences. Some improved performance. Others reduced efficiency or created weaknesses discovered decades later. The vessel became a layered object whose current form no original engineer could have predicted completely. Maintenance records grew into one of the largest archives aboard. Technicians studied the ancestry of machines, tracing a malfunction through centuries of modifications. A water processor in the northern agricultural ring contained a control system derived from a design used in early propulsion tests. Its outer casing had once been part of a launch fuel tank. Nothing aboard retained a simple identity. The possibility of an uninhabitable destination gave this aging machinery greater significance. The ship may need to support the population after arrival for centuries. It could no longer be treated as a vehicle approaching retirement. Every system had to remain capable of indefinite renewal. The planet's uncertainty turned the vessel itself into the only confirmed habitable world within reach. The ship's forests had been planted to preserve air, food, genetic diversity, and psychological health. Over generations, they also became evidence that a world could be created without a planet. Trees grew beneath controlled light inside rotating cylinders. Streams followed channels shaped by engineers. Rain fell according to schedules determined by agricultural and atmospheric needs. Children ran through these environments without finding them artificial. The curve of the habitat rose in the distance and continued above their heads. The opposite landscape appeared in the sky, separated by open air and the central axis. For those born aboard, this geometry belonged to nature. The planetary destination acquired a growing strangeness. Open horizons, uncontrolled weather, insects without monitoring tags, and water extending beyond engineered boundaries seemed magnificent and dangerous. A forest with no atmosphere system behind it required intellectual effort to imagine. Some citizens began asking whether settlement would represent liberation or exposure. The ship's ecosystem was fragile, though every part of it could be measured. A natural planet contained systems too large and complex for complete control. The settlers would enter air they had not manufactured, drink water carrying unknown chemistry, and walk upon geology whose deeper processes remained uncertain. The promise of a home beneath an open sky had been created by people who remembered Earth. Their descendants had learned to trust walls. During the 2nd century, the ship received a new series of observations showing a possible increase in the target star's activity. Dark regions on the stellar surface, repeated flares, and high-energy emissions suggested a cycle stronger than earlier estimates. The measurements covered only a small fraction of the star's long history, leaving scientists uncertain whether they represented an exceptional period or a regular pattern. The destination planet orbited close enough to receive the full intensity of those eruptions. A strong magnetic field could deflect part of the charged material. A dense atmosphere could absorb radiation in its upper layers. Without adequate protection, repeated stellar storms might gradually strip the air and alter surface chemistry. The ship could not measure the planet's magnetic field directly with confidence. Some models predicted an active interior capable of generating one. Others suggested that tidal locking had slowed rotation and weakened the dynamo, although the relationship remained more complicated than a simple rotation rate. The passengers learned another form of uncertainty. Habitability depended upon invisible protection inside a planet they could not touch. Oceans and clouds mattered, along with the movement of molten material thousands of kilometers beneath the surface. The destination's future could be decided by the cooling of its core. The possibility of a fading magnetic field entered popular culture. Poets described a shield weakening around a sleeping world. Children played games in which one group represented the atmosphere and another the stellar wind. Religious teachers used the image to speak about protection, sacrifice, and the unseen structures sustaining life. Scientists resisted the simplification. A planet without a strong global magnetic field could retain an atmosphere under certain conditions. A magnetic field did not guarantee safety. Atmospheric composition, gravity, stellar wind, geological activity, and time all interacted. Public imagination preferred a single hidden heart. The planet was alive if its interior still moved and vulnerable if it had grown cold. The metaphor connected the distant world with the ship, whose own survival depended upon engines, pumps, and circulating fluids hidden behind walls. People began referring to the vessel's reactor complex as the second core. The first belonged to the destination. The second traveled toward it, carrying life across the interval. The society aboard became increasingly skilled at preparing for incompatible futures. Agricultural teams developed crops for different atmospheric pressures, day lengths, light spectra, and soil chemistries. Medical researchers studied adaptation to stronger or weaker gravity. Construction groups designed surface habitats, floating stations, underground settlements, and orbital colonies. This work protected the mission and transformed education into continuous contingency planning. Students no longer trained for one arrival. They learned families of solutions branching from data that might change before adulthood. The abundance of scenarios created fatigue. A person could spend decades designing equipment for an ocean world and learn that the latest evidence favored a dry surface. Entire careers followed worlds that existed only inside simulations. Engineers built prototypes for environments nobody would confirm during their lifetime. Some found meaning in the preparation itself. Each solution expanded the civilization's ability to survive elsewhere. The destination served as a laboratory for imagining every plausible planet. The ship became more adaptable through the discipline of uncertainty. Others saw wasted lives. Their labor answered questions nature had already resolved at the destination, while the answer remained trapped ahead. The planet possessed a present. The travelers possessed models. 1,000 social practices formed around delayed knowledge. Scientific announcements were released with dates marking both observation and reception. Citizens learned to ask when the light had left the planet. Public displays showed 2 clocks: ship time and destination image time. The image time calendar moved through years that had already passed on the planet. A festival celebrated the moment when the newest observations crossed an ancient seasonal boundary. People spoke about storms that had ended centuries earlier as current events because their evidence had only just arrived. This produced an unusual relationship with history. The planet's past unfolded gradually aboard the ship. Each new transmission revealed a later chapter, although that chapter still belonged to an era long finished at the destination. The passengers watched the world age from a distance while knowing its unseen present aged faster than their knowledge. The effect resembled receiving letters from a person whose life had already continued beyond every message. Joy and warning arrived together, each unable to describe what had happened next. Communication with Earth added another layer of delayed time. Reports from the destination reached Earth first, were studied by scientists, and were transmitted toward the ship. The passengers received interpretations of ancient planetary light from an Earth that had itself moved years into the past by the time the message arrived. Questions sent back required long intervals for answers. Researchers aboard could challenge a model and wait through a substantial portion of their careers for a response. Scientific conversation became a project shared between generations. A student might complete work begun by a grandparent and receive an answer addressed to someone already dead. Earth's institutions also changed. Universities merged, agencies disappeared, and scientific languages evolved. The ship maintained translation systems and historical guides to understand references from a society continuing beyond them. Eventually, messages arrived from organizations unknown to anyone aboard. The connection remained valuable because Earth possessed telescopes, industries, and populations far larger than those of the vessel. It also reminded the passengers that their mission belonged to another society's past. Earth could advise them without sharing the consequences of arrival. In the ship's 218th year, Earth transmitted evidence of oxygen in the destination's atmosphere at a concentration higher than earlier estimates. The announcement spread through every habitat before the full report had been reviewed. Bells sounded in public gardens. Families gathered beneath the illuminated globe. The old hope of a living world returned with immense force. Researchers urged caution. Oxygen can accumulate through life, although certain combinations of water loss, stellar radiation, and atmospheric chemistry can also produce it without organisms. The planet might possess forests, microbial oceans, sterile rock, or a surface left dry after its water escaped. The signal required context from other gases and seasonal patterns. The public heard the caution and celebrated anyway. Centuries of uncertainty had created a hunger for one favorable sign. Children born that year received names associated with air, leaves, and oceans. A new political movement demanded that the planet be recognized as inhabited until evidence showed otherwise. This reversal created a different fear. A living planet would offer a biosphere and potential danger. Human arrival could contaminate an independent evolution. Native organisms might produce toxins, pathogens, or chemical structures incompatible with terrestrial life. Settlement would become an encounter rather than an occupation of empty land. The destination could be too alive for humanity to use safely. Planetary protection had been included in the mission charter, written during an age when no life beyond Earth had been confirmed. The document prohibited irreversible contamination until adequate surveys were completed. It offered limited guidance for a generation ship whose inhabitants needed resources, territory, and a permanent home. If microbial life covered the surface, the settlers would face a moral decision with practical consequences. Earth organisms released into the environment could overwhelm local ecosystems or be destroyed by them. Native chemistry might enter human habitats through dust, water, and air. A planet habitable in temperature and pressure could remain biologically hostile. Quarantine might last decades. Robotic laboratories would sample the upper atmosphere, surface, oceans, and subsurface. Humans could wait in orbit while their ship continued aging. A world physically capable of supporting them would remain forbidden until science reduced risks that could never be eliminated completely. Some citizens argued that survival granted them the right to settle. Their ancestors had crossed centuries toward the planet. Others believed the discovery of a second genesis of life would impose a duty greater than the mission's original purpose. Destroying an independent biosphere would erase something that may have occurred only a few times in the galaxy. The planet's habitability and humanity's moral access to it became separate questions. The debate reached into reproductive planning. Population forecasts had assumed expansion after arrival. Families expected restrictions aboard the ship to ease once new habitats and resources became available. If settlement were delayed or prohibited, the vessel would need to maintain tight demographic control for additional generations. Young adults questioned why their family lives should remain constrained to protect organisms that might consist only of simple cells. Scientists answered that the biosphere could contain complexity invisible from a distance. The argument turned upon beings nobody had observed directly. The mission's ethics had always favored future people over present comfort. The generation ship existed because founders had sacrificed for descendants. Now passengers were asked to extend similar consideration toward possible life ahead. The destination had acquired another identity. It was once a refuge, then an uncertain environment, and now a potential world with its own claim to continue undisturbed. In the 3rd century, a malfunction in the main observatory damaged the ship's ability to analyze faint planetary signals. Replacement components required a level of precision no longer available in local manufacturing. The vessel could still receive data transmitted by Earth, though it lost much of its independent capacity. The failure exposed the fragility of knowledge. The population had assumed that observation would improve continuously as the ship approached. Distance was decreasing, yet the instruments interpreting the planet were aging faster than local industry could replace them. A 20-year restoration program began. Engineers rebuilt fabrication systems, recovered archived techniques, and trained a new generation of optical specialists. The project consumed resources needed elsewhere. Several agricultural expansions were postponed. When the observatory returned to service, its first image of the destination remained a point of light. The improvement lay inside spectra, polarization, and subtle variations no unaided eye could understand. Thousands of lives had supported an instrument whose output required expert interpretation. The society celebrated because it had restored the ability to ask the planet questions, even when the answers remained ambiguous. The ship's oldest districts began to carry a sense of geological time. Walls had been rebuilt repeatedly while retaining marks from early construction. Layers of conduit revealed different technical periods. Archaeologists studied sealed compartments containing tools, packaging, clothing, and personal objects from the founders. A museum preserved one of the original destination displays. Its rendering showed blue oceans and green continents with a confidence later generations found almost painful. The label explained that the image had been created for public communication and had never represented direct observation. Visitors stood before it in silence. Some saw naive propaganda. Others saw the psychological courage required to begin a journey without certainty. The founders had needed an image strong enough to carry human intention into darkness. The museum became a place where anger toward the past softened without disappearing. The launch generation had made assumptions, simplified risks, and passed consequences to descendants. It had also built the only world those descendants had ever known. A movement called the native ship philosophy emerged during the 4th century. Its followers argued that the civilization had already reached its true destination. The ship contained human life, history, ecosystems, industry, and social meaning. Its movement through space did not make it incomplete. They supported entering the target system for resources while preserving the vessel as the principal habitat. Planets would become research sites and sources of material. Expansion would occur through additional orbital structures built from asteroids and moons. Human life would remain within environments designed for it. The movement attracted people who feared open planetary conditions and those who valued the ship's culture. Critics described it as surrender, an inability to complete the purpose for which generations had labored. The disagreement remained peaceful because arrival lay far ahead. Each side could postpone final decisions to descendants. This habit became a defining feature of the voyage. The most difficult choices were inherited forward, protected by distance from immediate consequence. Eventually, a generation would run out of descendants to whom it could pass the decision. The possibility that the planet had already become uninhabitable produced a particular kind of anxiety. A disaster there could have happened before the ship launched. The travelers might be moving toward a dead world while celebrating old evidence of oceans and air. A large impact could have darkened the atmosphere or altered the climate. A period of extreme volcanism could have filled the sky with gases. The star could have produced an exceptional sequence of eruptions. Orbital interactions with another planet might have changed the target's eccentricity or stability. Most of these events were improbable within a few centuries. The mission itself belonged to the realm of low-probability, high-consequence decisions. The passengers had learned that small chances become emotionally immense when no alternative home exists. Public health teams recognized a condition called destination dread. Patients described dreams of arriving above empty oceans, frozen continents, or a planet stripped to rock. Some dreamed of cities on the surface, evidence that another civilization had appeared during the journey and would reject them. Others imagined finding no planet at all. Therapists treated the anxiety without being able to challenge its central premise. The feared outcome remained possible. The society created rituals for uncertainty. Once each year, observation teams presented several complete versions of the destination based upon current data. One model showed a temperate ocean world. Another showed a dry planet with oxygen produced by water loss. A third contained microbial life beneath clouds. A fourth placed most habitable conditions on the dark side beneath a layer of ice. Citizens walked through immersive simulations of each world. They experienced winds, gravity, light, and landscapes generated from scientific models. The ceremony prevented one image from becoming absolute. Children enjoyed the variety. Adults often found it unsettling. Each simulation could become the home of their descendants, and most could disappear after the next major observation. The ritual taught a difficult cultural skill: commitment without certainty. The passengers continued maintaining the mission while accepting that its conclusion could differ from every hope carried at departure. The ship passed the midpoint of its journey without a physical marker. Navigation systems announced the event according to distance, velocity, and the planned deceleration profile. Celebrations filled the habitats, though many people felt the strange weight of irreversible progress. Earth lay farther behind than the target lay ahead. Communication with home had become deeply delayed. Turning around would take longer than continuing. The destination's gravity had not yet touched the ship in any meaningful way, and its star remained one point among many. The midpoint revealed how little the visible universe acknowledged human milestones. No boundary crossed the hull. The surrounding interstellar medium changed gradually. The ship declared itself halfway because its own plans required the concept. From that year onward, public language shifted. The target was increasingly called the approaching system. Maps enlarged it. The destination star acquired a visible motion against the background through precise instruments. Its light grew slightly brighter. The planet remained hidden within that light, continuing its unseen history. Several decades after the midpoint, a faint periodic change appeared in the planet's reflected light. Researchers interpreted it as a possible alteration in cloud cover or surface reflectivity. The pattern differed from observations transmitted centuries earlier. Some models suggested expanding ice. Others produced changes in vegetation-like pigments, ocean circulation, volcanic aerosols, or observational noise. The data established that the planet was dynamic and failed to reveal the direction of change. The public response was more restrained than in earlier centuries. The society had matured around ambiguity. News organizations presented probability ranges. Schools waited before creating educational material. Political groups still selected interpretations supporting their preferred future. The native ship movement described the change as further evidence against surface dependence. Settlement advocates argued that a changing climate indicated an active planet rather than a dead one. Planetary protection groups considered it a possible sign of a biosphere undergoing seasonal transformation. One set of photons entered the ship and became several futures. The destination star's light influenced agriculture long before arrival. Engineers developed lamps reproducing its spectrum, allowing crops to grow under the wavelengths they might receive on the planet. Plants changed subtly across generations of selection. Some varieties adapted well to the redder illumination. Their leaves became darker, absorbing more available light. Others grew slowly or developed nutritional deficiencies. Researchers adjusted genes, soil microorganisms, and cultivation methods. These experimental gardens became culturally significant. People called them the first sun chambers. Visitors entered beneath a light closer to the one their descendants might see. The color altered skin, walls, and water. Familiar plants appeared almost foreign. For many passengers, this was the closest experience of the destination available during life. They sat beneath an artificial version of its star and listened to wind generated by hidden fans. The planet remained unreachable, though part of its physical environment had entered the ship through measured light. The ship's population had changed enough that the people approaching the system would share no direct cultural continuity with Earth beyond archives and institutions. Their language descended from several launch languages blended across habitats. Their bodies had developed under artificial gravity and controlled light. Their immune systems belonged to an ecosystem isolated for centuries. Planetary settlement would expose both sides to biological unfamiliarity. Earth organisms aboard had co-evolved within the ship's closed environment. Harmless microbes could behave differently under planetary chemistry. The settlers themselves might respond poorly to natural allergens, minerals, or atmospheric compounds. Medical teams prepared gradual exposure protocols. Initial habitats would remain sealed. Air, water, and soil would pass through extensive analysis. Settlers might spend years on the surface without breathing the external atmosphere directly, even when its oxygen and pressure appeared suitable. The dream of removing a helmet beneath another sky became less central. Survival required patience after centuries of travel. Arrival would begin another long period of separation from the world around them. A robotic precursor was launched during the ship's final century of cruise. It carried no people and possessed a lighter structure capable of accelerating ahead. Its purpose was to reach the target system decades before the generation ship, survey the planet, and transmit data back. The probe represented the first opportunity to receive close observations before committing the vessel to final deceleration. Its engines burned brightly as it left, becoming a point of light ahead of the ship. Generations had waited for that departure. The probe's journey remained long enough for children watching its launch to become old before its most important data arrived. Society reorganized around the expected signal. New scientific institutions were created. Political procedures defined who could alter the arrival plan in response. The probe carried cameras, atmospheric instruments, radar, landers, balloons, ocean samplers, and small devices designed to search for complex chemistry. It also carried the accumulated fear of the entire voyage. A machine built aboard the ship would reach the planet first and determine whether the civilization behind it possessed a surface future. The decades of waiting became more difficult as the destination grew closer. Telescopes aboard improved their observations, though close detail remained beyond them. The precursor's transmissions during transit confirmed its health and offered no planetary answers. Citizens debated what data would be sufficient for landing. Some demanded direct evidence of safe air and water. Others accepted settlement within sealed habitats under almost any surface conditions. The ship could survive in orbit, though long-term expansion would benefit from local resources. The legal system established several classifications. Green status permitted staged settlement. Amber status allowed orbital operations and restricted surface missions. Red status required avoidance of the planet while preserving other options within the system. Black status indicated a threat to the vessel itself, such as extreme stellar activity or unstable orbital conditions. Every classification compressed a world into a color because decisions had to be made before every uncertainty could be resolved. The first close images arrived from the precursor after a delay of several years. They showed a complete planet larger than any previous observation, covered by clouds arranged in immense spirals and bands. Dark regions appeared through gaps. Light reflected from what could be oceans, ice, mineral plains, or combinations of all three. People gathered in every public space. Some wept before the images had been analyzed. The planet no longer resembled an abstract point. It possessed weather. It cast a shadow. A moon crossed part of its surface during one transmission. The images also showed a broad, pale region near one pole, larger than predicted by early climate models. Scientists could not determine whether it consisted of ice, high clouds, or a reflective mineral surface. The illuminated hemisphere contained strong storms. The atmosphere appeared denser than feared and chemically more complex than expected. The destination was real, beautiful, and unresolved. Spectral data followed. The atmosphere contained substantial oxygen, nitrogen-like gases, water vapor, carbon dioxide, and trace compounds whose origins were uncertain. Pressure estimates fell within a range that could allow surface operations with manageable protection. Temperatures varied widely across latitude and altitude. The results seemed favorable until measurements revealed high concentrations of a reactive gas near the lower atmosphere. It could arise from active biology, unusual geology, or interactions driven by stellar radiation. In sufficient quantities, it might damage human tissue and terrestrial crops. The atmosphere could be breathable after filtration. Direct exposure remained uncertain. The dream of walking outside without protection receded again. Ocean observations revealed strong absorption patterns, suggesting dissolved compounds unlike those common in Earth's seas. No evidence showed whether these substances were toxic, harmless, or biological. The probe prepared its landers while the ship's scientists worked through data that multiplied faster than conclusions. Habitability had never meant similarity. The planet could support liquid water and active chemistry while remaining profoundly foreign to the organisms arriving from Earth. The first lander entered the atmosphere above a dark, equatorial region. Its cameras transmitted cloud layers illuminated by the red-orange star. Lightning moved across distant storms. Winds changed direction with altitude. The descent lasted hours under parachutes and controlled flight. The surface appeared beneath a broken layer of cloud, black ridges, shallow water, and broad fields covered by a material whose color changed with viewing angle. The lander touched down on stone near the edge of a basin. Pressure, temperature, and wind remained within survivable engineering ranges. The ground contained water ice beneath a mineral crust. The air would require treatment, though a sealed habitat could operate there. Then the biological instruments detected complex organic structures distributed across the wet ground. Their patterns repeated with variations resembling growth. The camera showed no movement. Chemical analysis suggested active reactions maintained far from equilibrium. The planet possessed something that might be life. The signal transformed the ship. Celebration, fear, reverence, and political urgency spread together. Humanity had crossed centuries toward a world that may contain an independent biology. The planet had remained habitable, though its habitability belonged to organisms already present. Scientists warned that confirmation required multiple lines of evidence. Complex chemistry can form without life. The probe deployed microscopic imagers, isotope analyzers, and sealed sample chambers. Each result strengthened the biological interpretation without producing a single dramatic moment of proof. The possible organisms used solvents, membranes, or structural compounds that differed from familiar terrestrial cells. Their chemistry operated within films of water among minerals. They appeared simple in scale and vast in distribution. A living film may have covered parts of the planet for millions of years. The arriving civilization numbered thousands and carried an ecosystem derived from Earth. Any uncontrolled contact could change both worlds permanently. The destination had survived. Its survival created a barrier to human settlement that no launch-era image had anticipated fully. The Council declared amber status. The ship would decelerate into the system and remain away from the planet until further study. Robotic missions would continue. Human landing was postponed indefinitely. Settlement advocates organized the largest demonstrations in the vessel's history. They accepted quarantine and environmental protection, though they rejected permanent exclusion. The ship had limited space, aging systems, and a population prepared to expand. The planet contained continents and resources capable of supporting billions under controlled development. Protection groups argued that the mission had no moral right to place terrestrial life into an independent biosphere. Even sealed settlements create leaks, accidents, and biological exchange. The history of the ship itself demonstrated that perfect containment across centuries was impossible. Native ship communities proposed construction in the system's asteroid belt and on airless moons. The planet would remain a scientific sanctuary. Its presence would provide knowledge, gravity-assisted transport, and perhaps carefully sterilized resources from lifeless regions. The conflict could no longer be passed forward through distance. Engines were preparing to slow. The choice belonged to the living generation. The precursor then transmitted its most alarming discovery. Measurements of the polar region showed rapid ice loss compared with observations recorded during the ship's journey. The planet was warming. The change appeared connected to a shift in stellar output and atmospheric composition. The rate remained difficult to determine because earlier data had limited resolution. The warming could stabilize. It could also drive feedbacks involving water vapor, clouds, oceans, and greenhouse gases. A world suitable for local organisms might move toward conditions dangerous for both native life and human settlement. The mission now faced two responsibilities that could conflict. Protecting the biosphere might require intervention. Human technology could alter atmospheric chemistry, reflect stellar energy, or preserve samples. Intervention could also damage processes poorly understood. The passengers had spent centuries fearing a dead planet. They arrived to find a living world whose future may be unstable. Some scientists propose that the warming pattern formed part of a long, natural cycle. The planet's oceans, orbit, and star produced variations across centuries. The ship's observation window remained too short to determine whether the current trend led toward catastrophe. Others saw evidence of a threshold. Ice loss reduced reflectivity, increasing absorbed heat. Warmer oceans released gases that strengthened atmospheric warming. Cloud changes could amplify or reduce the process. The models diverged according to assumptions that only decades of close data could resolve. The generation ship could wait in orbit and study. Its own condition imposed another clock. Several major systems required access to external raw material. Population planning assumed expansion within 50 years. Remaining entirely aboard increased technical and social risk. The planet's climate and the ship's civilization both demanded time. Neither could guarantee it. The system contained 2 small moons and a broad population of asteroids. Robotic surveys found water, metals, carbon compounds, and silicate material sufficient for construction. The native ship plan became practical. New rotating habitats could be built without touching the planet. This route would preserve the biosphere and provide space for population growth. It required decades of mining, manufacturing, and orbital engineering. The first settlers would live in incomplete structures exposed to radiation and dependent upon the ancient ship. The planet would remain visible throughout their lives, a blue and dark world beneath cloud, close enough to dominate the sky and restricted by law. Children born in orbital habitats might view its surface as their ancestors once viewed Earth, a natural world preserved behind distance and prohibition. The mission could succeed within the star system while never reaching the destination in the form imagined at launch. The phrase "reach the destination" became politically unstable. The vessel would enter the planet's orbit. Its probes had touched the surface. Human beings would see the world with their own eyes from space. Some argued that the journey was complete. Others believed arrival required human footprints, settlements, agriculture, birth, and burial on the planet. Orbit remained another form of waiting. The purpose of a generation ship had been to establish humanity beneath another star, not to preserve permanent distance from the most habitable world there. The disagreement revealed how goals change during long projects. The launch documents described settlement because no independent biosphere had been known. New evidence altered the moral landscape. Fidelity to the mission could involve carrying its deeper values forward rather than reproducing every original action. The ship had been sent to preserve life. The planet forced its descendants to decide whose life that purpose included. The final deceleration began under a sky filled with the destination star. The main engines had remained mostly silent for centuries. Engineers from several generations had rebuilt fuel systems, tested ignition chambers, and replaced control structures. No full-scale test could reproduce the forces of the coming burn. Habitats were secured. Agricultural systems reduced vulnerable crops. Citizens entered protected sections while the ship rotated into position. The engines ignited with a vibration that moved through every wall and body. For months, the vessel surrendered the speed accumulated since departure. The star stopped growing ahead and began taking its place as the center of a new sky. The planet's orbital motion became visible to navigation systems. Its moon separated into a distinct world. The ship had spent centuries falling toward a possibility. Deceleration turned that possibility into a place from which departure would again require immense effort. During the burn, a coolant failure developed in one propulsion module. Automatic systems reduced thrust. The ship's trajectory began drifting from the planned capture corridor. Engineers had hours to choose between shutting down the affected engine and risking an extended pass through the system, or maintaining operation long enough to complete the maneuver. The repair teams entered compartments never intended for human access during full thrust. Artificial gravity from acceleration changed every movement. Heat rose behind shielding. The destination planet filled external displays, while the ship's ability to remain near it depended upon valves, pipes, and decisions made inside a narrow machinery space. The fault was repaired with a replacement assembly manufactured from material once used in an agricultural habitat. The engines returned to planned output. The vessel entered a long orbit around the star. Centuries of scientific uncertainty had nearly been rendered irrelevant by one mechanical failure. The most habitable planet in the galaxy would offer no refuge to a ship unable to slow. The first direct human view of the planet occurred through heavily filtered windows and external cameras. It appeared larger than Earth's moon had appeared from the old surface, crossed by weather systems and dark seas. The illuminated hemisphere carried colors no artist had predicted accurately. The crew could see the polar region shrinking through a sequence of images. Storms formed and dissolved. Light moved across the atmosphere. The planet was no longer an old photograph arriving from the past. Its current light reached the ship after minutes. For the first time, the civilization and its destination shared nearly the same present. Questions sent to orbiting probes returned within hours. Weather forecasts described tomorrow rather than an ancient century. The historical separation that had defined the voyage collapsed. The world remained uncertain, though its uncertainty could finally be investigated directly. Humanity established its first settlement on a small moon. The surface contained no atmosphere and no native chemistry resembling life. Habitats were buried beneath regolith for radiation shielding. Ice from shadowed regions supplied water and fuel. The planet hung above the horizon as a large moving globe. The moonbase began as an extension of the generation ship and developed into the first independent community of the system. Factories processed local material. New pressure vessels were constructed. Population restrictions eased gradually. From the moon, scientists directed increasingly complex missions toward the planet. Sterile aircraft traveled through the atmosphere. Submersibles entered the oceans. Drills collected material beneath the surface. Every instrument was designed to prevent terrestrial contamination, although absolute sterility remained an unreachable ideal. The native biosphere proved widespread and chemically distinct. It occupied water, rock pores, coastal films, and deep subsurface environments. No animals, forests, or intelligent beings appeared. Complexity existed through microbial communities whose interactions shaped parts of the atmosphere. The smallest life forms created the largest moral boundary humanity had ever encountered. Climate observations accumulated over decades. The warming continued unevenly. Some regions became wetter, others drier. Polar ice retreated while cloud systems increased over the illuminated ocean. The biosphere changed with the climate, expanding in some areas and disappearing in others. The star had entered a period of elevated activity that might last centuries. Human intervention could reduce certain effects, though every proposal carried uncertainty. Seeding the upper atmosphere with reflective particles could alter light levels for native organisms. Building orbital shades could cool selected regions while changing winds. Removing greenhouse gases could disturb chemistry maintained by the biosphere itself. A civilization skilled enough to cross interstellar space discovered that planetary control remained more difficult than maintaining a ship. The vessel had boundaries, sensors, and designed systems. The planet contained processes extending through atmosphere, ocean, crust, and life. The passengers had imagined arrival as freedom from machinery. Their descendants found themselves considering machinery on a planetary scale. After years of debate, limited intervention began. Orbital structures reduced a small fraction of stellar energy during the most intense activity. The system was adjustable and reversible. Native environments were monitored continuously. Humanity accepted responsibility without claiming complete understanding. The work gave the civilization a new purpose. The mission shifted from settlement toward coexistence and preservation. Habitats expanded through the moon system and asteroid belt. The planet became a protected world studied through carefully controlled contact. Some people continued demanding surface cities. Their movement survived across generations, especially as population and orbital infrastructure grew. The legal prohibition on permanent settlement remained subject to periodic review. The destination would never become politically settled. Its meaning evolved with every discovery. Children born in the new system learned a different version of the voyage. The planet had once been observed only through ancient light. Their ancestors traveled without knowing whether it would hold air, water, or life. The uncertainty became history rather than daily fear. They could look upward and see the actual world. School lessons included live weather images and delayed recordings from surface probes measured in minutes. The strange condition of traveling toward a past image became difficult for them to imagine. Some visited the generation ship, preserved in orbit as a living habitat and historical site. They walked through old observation halls where their ancestors had studied blurred spectra. The original paintings of oceans appeared beside direct images showing landscapes far more complex. The ship had reached the system and remained essential. It had failed to become obsolete, just as earlier generations predicted. Its oldest forests continued growing. Its engines rested after the final burn. Entire districts were maintained as homes. The vessel had arrived without delivering its people onto the planet's soil. Centuries after arrival, historians continued debating whether the mission had succeeded. Humanity survived beneath another star. The generation ship completed its voyage. New habitats spread throughout the system. The native planet remained largely untouched by human settlement. The launched generation would have recognized part of this future and misunderstood much of it. Their images had shown a second Earth waiting for cities. The real world contained life organized through chemistry and environments with no human analog. It required protection more urgently than colonization. The mission's deepest achievement may have been its capacity to change. A rigid civilization could have forced the planet into an ancient plan, damaging the biosphere and itself. The descendants preserved the purpose of survival while allowing evidence to transform the method. The planet had never promised them a home. It had existed according to its own history, receiving their arrival as another event in a long sequence of climate, geology, and life. The anxiety of the voyage never disappeared completely. It entered the culture of the new civilization as caution toward distant certainty. Telescopes discovered other planets around other stars. Some appeared warmer, greener, or more familiar than the world nearby. No one described them as guaranteed homes. Every image was marked with the age of the light. Every model was presented beside alternatives. Children learned that distance turns observation into history and desire into speculation. Another generation ship might someday depart. Its destination would be studied with instruments far superior to those available to the first mission. Robotic probes might arrive before the passengers. Communication networks could provide richer data. The central uncertainty would remain. A planet continues living while travelers cross the distance. Atmospheres change, stars flare, climates move through thresholds. Life alters worlds. No departure can freeze a destination in the condition that inspired the journey. Interstellar exploration means traveling toward a future that refuses to be observed in advance. The original generation ship still crossed the planet's night sky as a bright artificial star. People on the moon could follow its motion. Instruments on the surface occasionally captured its reflection in dark water. Inside the ship, one hull preserved the final full image received before departure from Earth. Beside it hung the first close photograph from the precursor and a current view transmitted from orbit. The three worlds appeared related and different. The first was an imagined destination built from scarce light. The second was a planet emerging from uncertainty. The third was a living system humanity had begun to know without possessing. Visitors stood before the sequence and understood that the voyage had covered more than distance. It crossed from projection into encounter, from inherited hope into responsibility. A generation ship may never reach its destination because the destination can disappear while the ship is traveling. Oceans can evaporate, atmospheres can escape, climates can shift, and stars can alter the conditions that once made a world promising. It may also fail to arrive because the planet remains alive in a way the travelers never expected. The world can become ethically inaccessible, biologically dangerous, or too valuable to transform into another human environment. The ship can reach the correct coordinates and discover that the original destination existed only in old light, scientific models, and the needs of the people who launched it. This does not make the voyage meaningless. The civilization carried through the darkness can adapt, build habitats, choose another world, or remain within the vessel that protected it. Arrival can take forms unavailable to the founders. The journey begins with a planet ahead. Over centuries, the ship becomes a world of its own. When the destination finally enters the present, humanity must decide whether reaching it means landing, surviving nearby, understanding it, or allowing it to remain beyond human occupation. The planet will never be waiting. It will be living through its own future, long before the travelers are close enough to see.